Okay, for this section, I'm going to split it into two videos. We're going to do one video on um, e to the x using other bases. So we're going to look at a to the x. The next video, we're going to look at natural or logarithms with bases other than e. So log base a of x. Um, to start, though, we are going to hit the final form of the power rule. Power rule, if you remember, is the derivative of x to the n is n x to the n minus 1. Technically, until this point, we haven't been able to use irrational numbers, but now with our exponentials and logarithms, we can do that. So it just works exactly like you would expect. The derivative of x to the square root of 2 power would be the square root of 2, x to the square root of 2 minus 1. Nothing unexpected here. Remember that pi is a number. So this next example, the derivative of sine x to the pi power would be pi sine x to the pi minus 1 power times the derivative of the inside, which is cosine. That's the chain rule, and we're done. So nothing too fancy there, just a formal technicality and as far as proofs go. So moving on, we want to take the derivative of an integral of a to the x. Well, we can't. So to do so, we would need to change the form by adding in e to the x. If we do that, then we change this to e, bring that power in front, so we have x, natural log of a. So now, if we take the derivative of a to the x, well, we can do that little substitution, and we can say the derivative of e to the x, natural log of a. Well, we know the derivative of e. We rewrite the whole thing, e to the x, natural log of a. So we rewrite the whole thing times the derivative of this. Well, natural log of a is just a constant times x. Well, the derivative of a constant times x is the constant, natural log of a. Well, what is this? We look back up here, that is a to the x. So the derivative of a to the x is a to the x with an extra multiplier of natural log of a. So it works just like e to the x. We're going to rewrite the whole thing, then do any chain rules needed, and we're going to have a factor of the natural log of the base, which we could use if this was e. Natural log of e is just 1, so it would be a factor of 1. So this works just the same way as e to the x, just with this extra factor. So looking at this example here, the derivative of 3 to the x is just rewrite it, 3 to the x, times the factor of natural log of the base, which is 3. So 3 to the x, natural log of 3. Same thing on this next example. Derivative of 3 to the negative x. We rewrite it, 3 to the negative x. We get our factor of their base, so natural log of 3, and we get the chain rule of negative 1. This to here, we're going to chain. This is the inside part as far as the chain rule goes. Okay, super simple. Trying to make it a little more complicated for us. We get a trig function in here. Again, we're going to rewrite it just like we would if it was e to the x. So we have 3 sine to the x, or 3 to the sine x, times chain rule, cosine x. So we chained this to here. Now, part D here is a little bit harder because we have x to the x. We don't have a constant base or a constant exponent. We have to change, and we're going to do that similarly, and you don't have to memorize this. We had to change that just like we did earlier by raising this e to the natural log of x to the x. Well, again, we're going to take this power, we're going to move it down, so it's going to be the derivative of e to the x log n x. Okay, So, derivative of e to something is, we rewrite it. Then we're going to take the derivative of the inside. Well, the derivative of this is x times natural log of x. So we have to use the product rule, which is the first times the derivative of the second. The derivative of natural log is 1 over x plus the second natural log of x times the derivative of the first times 1. Okay, so let's look at these. We got three things to look at. We're going to look at this, we're going to look at this, and we're going to look at this. This, if we look, is just x to the x. X times 1 over x is 1, and then natural log of x times 1 is natural log of x. And you're simplified. I just thought that was an interesting problem. I like x to the x. It's interesting. Now, integral. So that's it for derivatives. You take the derivative, you multiply by natural log of the base. Integrals, slightly different. Do the integral a to the x dx. The derivative was multiplying by the natural log of the base, so the integral is just the opposite. It is dividing by the natural log of the base. So, looking at those, integral of 2 to the x is, we rewrite, we're going to, instead of multiplying by natural log of 2, we're going to divide by the natural log of 2. And our plus c. Here, it's not as straightforward because it doesn't quite match our pattern. It's got this extra little thing over here, so we try to do a u substitution. U equaling sine x. That's going to have to be a u at some point because that doesn't fit any pattern unless we make that a u. Du would be cosine x dx. So this is our dx, this is our u. Integral of 2 to the u du, which we just saw over here. So that's going to be 1 over natural log of 2, 2 to the u, plus c. Substitute back in, we get 1 over natural log of 2 times 2 to the sine x plus c. You can put that on top of that fraction, and both answers are okay. So that's it for derivatives and integrals.